Hello everyone. Today's topic is informed search. Sometimes informed search is also called as heuristic search. Now, informed search is defined as a method or as a trick or as a rule. It is defined as a rule or a piece of information that is used to make search or another problem solving method more effective and more efficient. Heuristic search is a method that provides a better guess about the correct choice to make at any junction that would be achieved by random guessing. A heuristic is a method that might not always find the best solution but is guaranteed to find a good solution in a reasonable time. By sacrificing completeness, it increases efficiency, useful in solving tough problems which could not be solved any other way. Solution take an infinite time or very long time to compute. So the classic example of Heuristic method is the traveling salesman problem. Now, what is the difference between informed search and uninformed search? Informed search, it uses knowledge for the searching process, and uninformed search, it does not use knowledge for searching process. Informed search, it finds solution more quickly. Uninformed search, it finds solution slow as compared to informed search. Informed search, it is highly efficient. In uninformed search, it is mandatory efficient. Informed search, cost is low, and uninformed search, cost is high. Informed search, it consumes less time and it consumes moderate time. It provides the direction regarding the solution. No suggestion is given regarding the solution in it. It provides the direction regarding the solution with the help of heuristic function. It is less lengthy with implementation. Uninformed search, it is more lengthy while implementation. For example, greedy search, A-star search, graph search, and uninformed search, DFS, depth first search, and breadth first search. Now, heuristic function. Heuristic function are the most common form in which additional knowledge of the problem is imparted to the search algorithm. The heuristic function is a way to inform the search about the direction to a goal. It provides an informed way to guess which neighbor of a node will lead to a goal. A heuristic function is a function that maps from problem state description to measure desirability, usually represented as a number weight. The value of a heuristic function at a given node in the search process gives a good estimate of that node being on the desired path. Solution. There are some features of heuristic function. It takes a state as an argument and returns a number that is the estimate of the merit of the state. It must provide a reasonable estimate of merit, the goal. It must be expensive to compute, and it overestimates the cost of the path to the goal from the node. Some important properties of heuristic function which evaluate its performance are completeness. An algorithm is said to be complete if it terminates with a solution when one exists. An algorithm is said to be complete if it terminates with a solution when one exists. Admissibility. An algorithm is called is admissible if it is guaranteed to return an optimal solution. However, whenever a solution exists. Dominance. An algorithm A1 is said to dominate A2 if every node expanded by A1 is also expanded by A2. Optimality. A solution to a problem is a path from initial state to the goal state. Solution quality is measured by the path cost function, and optimal solution has the lowest path cost among all solutions. An algorithm is said to be optimal over a class of algorithms if it dominates all members of the class. Next is monotonicity. Monotonicity. For all admissible heuristics, the cost of the evaluation function f never decrease in any of its path from the root. This property of heuristic is called monotonicity. Consistency. By consistency, we mean that the heuristic algorithm never reopen an already closed node. A heuristic is consistent if hn less than equals to cost n comma n dash plus hn dash. Every consistent heuristic is also admissible. Generate and test property. Test algorithm. Generate and test algorithm. In generate and test technique, generate will create possible solutions and the tester will evaluate each proposed solution, either accepting or rejecting that solution. It consists following steps. First is generate a possible solution. Second, test to see if this is the expected solution. Means test to see if it is actually a solution by comparing this to the set of acceptable goals state. Third, if the solution has been found, quit, else go to step 1. A potential solution that need to be generated very depending on the kinds of problems. For some problems, the possible solution may be particular points in the problem space, and for some problems pass from the start state. Generate and test is acceptable for simple problems, whereas it is inefficient for problems with large space. Best first search algorithm. Best first search is the most general form is a simple heuristic search algorithm. In BFS and DFS, when we are at a node, we can consider any of the adjacents as next node. So both BFS and DFS blindly explore paths without considering any cost or function. The idea of best first search is to use an evaluation function to decide which adjacent is most promising and then explore. But the best first search falls under the category of heuristic search or informed search. The evaluation function Fn is made up of two parts. These are the heuristic function Hn and estimated cost function is Gn. So Fn equals to Gn plus Hn. The best first search use the concept of priority queue and heuristic search. To search the graph space, the best first search method uses two lists for tracking the traversal: an open list which keeps track of the current immediate nodes available for traversal, and closed list that keeps track of the node already traversed. So we use a priority queue to store cost of nodes. So the implementation is a variation of BFS. We just need to change queue to priority queue. First, then algorithm of best first search. Create two empty lists. First, we have to create two empty lists, open and closed. Then start from the initial node, say n, capital N, and put into the ordered open list. Then repeat the next step until goal node is reached. If open list is empty, exit the loop returning first. Select the first oblique or top node, say n, in the open list and move it to the closed list. Also capture the information of the parent node. If n is a goal node, then move the node to the closed list and exit the loop, returning true. The solution can be found by backtracking the path. If n is not the goal node, expand node n to generate the immediate next node link to node n and all those to the open list. Record the nodes in the open list in ascending order according to the evaluation function. So, what are the advantages of best first search? Best first search can switch between BFS and DFS by gaining the advantage of both of the algorithms. And this algorithm is more efficient than BFS and DFS algorithm. And what are the disadvantages? It can behave as an unguided depth first search. In the worst case scenario, it can get stuck in a loop as DFS. The algorithm is not optimal. Thank you.